Hi students, good morning. Today we're going to go over day 6, proportional and non-proportional situations from tables. We're going to see if we can tell if a table is linear or non-linear and proportional or non-proportional. Now you guys already know if a table is linear or non-linear. We've done that already, so that's just a review. We calculate that by looking at the slope. And so what's new is to tell if a table is proportional or non-proportional. So you have a note sheet, so you don't have to write any of this down since it is a short period. But please follow along. So look at the next part of your note sheet, the rate of change. So you can tell if something is, if the rate of change, remember this is a slope, if the slope is constant, then it is linear. If it's linear, we're going to look at calculating k, which is just plain and simple y over x. If y over x is constant, then it's proportional. If y over x is not constant, it's non-proportional. So what does that mean? What does that look like in a graph? If this was a graph and k is constant, then your graph would go through the origin. And then for non-proportional, if your rate of change is constant, it's linear, but it's non-proportional, then that graph just doesn't go through the origin, but it is linear, it's a straight line. If your rate of change is variable, then it's automatically non-linear, non-proportional. So your graph could look, it could be curved or separate line segments. It can look like a few different things. Okay, so we're going to distinguish between proportional and non-proportional situations using a table. So if there is not a constant rate of change, remember that's your slope. If there's not a constant slope in the data displayed in the table, then the table represents a non-linear, non-proportional relationship. A linear relationship represented by a table is a proportional relationship when the quotient of each pair of numbers is constant. So that's where you calculate your k, and you're just going to put y over x, versus your slope is what? The change in y over the change in x. So this time for k, to tell if it's proportional, we're just taking a straight y over x. So you just look at the y value and you put it over the x value. Okay, so we're going to use this graphic organizer to help us. So if it's a table, we're going to look at, is y over x constant? Then this is your y-intercept, 0, 0, and it's proportional. If your y over x ratio is not constant, then it's non-proportional. All right, so pencils down. I'm going to do 2 examples. They are not on your note sheet, and you can just watch me do them. Okay, so we're going to decide if the table is linear or non-linear. Then we're going to decide if it's proportional or non-proportional. So first, linear or non-linear. We have to find the rate of change, which is your slope, your m. So the difference between 3 and 6 is an increase in 3. Between 6 and 12 is an increase of 6. All right, between 12 and 24, it's an increase of 12. Between 24 and 48, it's an increase of 24. So we're going to write the ratios. So the change in y over the change in x. So 12 over 3 is 4. And then 24 over 6 is 4. So your m is equal to 4. This is constant. So that means it's linear. And then we're going to find the y-intercept. So remember, on the y-intercept, x is always 0. So we're going to go backwards on our table. We're going to go back to where x is 0. So how do I go from 3 to 0? I'm going to take and I got to subtract 3. So I'm going to take the corresponding y change, and I'm going to do the opposite of this. I'm going to subtract 12. So 12 minus 12 is 0. So our y-intercept is 0, 0. So since the y-intercept's at 0, 0, it is proportional. Explain. The y-intercept is at 0, 0. All right, and then we're going to write our k values. So k is just y over x right here. So I take my y value, 12, and I put it over my x value, which is 3. So 12 over 3 is 4. And I do that for each item on the table. 24 over 6, 4. And then 48 over 12 is equal to 4. So your k is 4. So this is called the constant of proportionality. All right, next example. Again, it's just me. So again, we're going to start with our slope, our rate of change. So the change here is 10 plus 10 plus 10. And then from here, it increases by 5, it increases by 10, it increases by 5. So my ratios, the change in y over the change in x, so this is 1/2, 5 over 10 is 1/2. And then the next one we have, 10 over 10 is equal to 1. And we already have represented a 5 over 10, so I don't need to rewrite it. So since these are not the same, this is variable. So there's no slope, there's none. And so this would be nonlinear. And I cannot find the y-intercept. If it's not given on the table, then I cannot go back because I don't know how to go back to 0. I don't know, should I, like, since it's not constant, I don't know back, I can go back to 10, but then I don't know, should I pick a 5 or should I pick a 10 to subtract from? So I cannot find the y-intercept. And then automatically, if it's nonlinear, it is non-proportional. And you can say that it's nonlinear. So now we're going to write our k values. So 15 over 10, remember this is just y over x. So 15 over 10, I can divide them both by 5, so this would be 3 over 2. And then I have 20 over 20, which is 1. 30 over 30, 1 equals to 1. And then 35 over 40, I can simplify them both by 5, so this would be 7/8. So there is none on the k value, okay, because these are not constant. Okay, next up. This is the first example. We're going to do this one together. So the first thing we're going to do is find the rate of change, the slope. So let's go ahead and find the slope. So the difference here is 2, 2, and 2. So it increases by 2. This one decreases by 20. Here it's going to decrease by 20, and here decrease by 20. So your change in y over change in x, negative 20 over 2, which is negative 10. And they're all the same, so you can just put your m equals negative 10. So is this constant or variable? It's constant. So is it linear or nonlinear? It is linear. And then now we got to find the y-intercept. So see how this is a 2 right here? I want to go back to 0, so I would subtract 2. So I need to find a 2 up here in my change. Well, they're all 2, so I just pick one. And then you do the opposite of this. So since this is going down by 20, you are going to add 20 to 100. So 2 minus 2 is 0. 100 plus 20 is 120. This is your y-intercept. 0, 120. So is this proportional or non-proportional? Is y-intercept 0, 0? If no, then it is non-proportional. In order to be proportional, the y-intercept has to be at 0, 0. So what's my explanation? The y-intercept is not 0, 0. So now we're going to write all of our k values. Remember, k is just y over x. So I just take y, 100 over 2. So 100 over 2 is 50. And then 80 over 4 is 20. 60 over 6 is 10. And 40 over 8 is 5. So there is no k. So just put none. All right, next up. Here's another one. So why don't you go ahead and calculate the slope? Okay, the difference between 8 and 16, it increases by 8. 16 and 21, it increases by 5. And then here, 32 and 64, it increases by 32. And here, 64 and 84, it increases by 20. So we're going to write the change in y over change in x. 32 over 8 is 4, and 20 over 5 is 4. So my slope is 4. That would be constant. It's also, if it's constant slope, it's linear. And then the y-intercept. So remember, you have to go backwards 8. So here's an 8. The 8 doesn't always have to be your first change. It could be your second change or your third change. So you just have to find this number up here and get the corresponding change in y. So we're going to subtract 8. 8 minus 8 is 0. And then use this. So subtract 32. 32 minus 32 is 0. So your y-intercept is at 0, 0. And so that tells you it's proportional. And then your explanation, your y-intercept is 0, 0. Now you're going to write your k. So I want you to write all the ratios for the k. So y over x. Okay, you should have written 32 over 8 equals 4. 64 over 16 equals 4. And 84 over 21 equals 4. So your k is 4. We talked about this last week when we were going over some graphing. Or was it tables? I think we were going over tables. And I said if it's proportional, your slope and your constant of proportionality are the same. When it's proportional, these are a direct variation, so they should be the same. All right, next example is your turn. So the teacher's going to pause the video. She's going to let you work for a couple minutes, and then she's going to put the video back on, and I will go over the answers. So teacher, please pause the video. All right, so you should have had enough time to complete this. So the first thing you're going to do is you're going to find your slope. So this increases by 2, by 2, and by 2. So this increases by 6, by 6, and by 8. So right away, since all of these are different, and these are, or all these are the same, the change in x is the same, the change in y are different, I already know it's not going to be constant, right? It's nonlinear. So, but I still got to write up my proportions, or my ratios. So 6 over 2 is 3, and 8 over 2 is 4. So there is no slope, so you put none. So it's variable, and it's nonlinear. There's no y-intercept, so just put NA, because this graph could cross the y-axis, but I don't know what it is, because if I went back 2, I don't know to go back 6 or 8, so I don't know what it would be. And so this is non-proportional. And my explanation is it's nonlinear. And then my k values, 8 over 2 is 4, and then 14 over 4 is just 7 over 2, and 20 over 6 is just 10 over 3. And then 28 over 8, I can divide by 4. So 7 over 2. And so there is no k. Okay, so I hope this isn't very difficult for you. I don't think there's very much that is new here. But there's one more for you to do, so the teacher's going to pause the video. So teacher, please put the video on pause, and when all students look like they are finished, press play. All right, last example. So we're going to find the slope. So this increases by 7, this increases by 1, this increases by 3, this one increases by 35, this increases by 5, and this increases by 15. So my ratios, remember, is a change in y over change in x. So 7 over 35 is, I can divide them both by 7, is 1/5. And then 1 over 5 is just 1/5. And then the last one, 3 over 15, I can divide them both by 3, and that equals 1/5. So my m is 1/5. So this is constant. So it's linear. My y-intercept. So I know the x is 0, so we got to go backwards. So here's my x. I'm going to go backwards by what? By 5. I got to subtract 5. So here's a 5. Where's the corresponding change? 1. So I'm going to subtract 1. So 5 minus 5 is 0. 1 minus 1 is 0. So my y-intercept is at 0, 0. When your y-intercept is 0, 0, it is proportional. Your explanation, the y-intercept is 0, 0. Your k values, remember it's y over x, so 1 over 5, I can't simplify that. 8 over 40 is 1/5. 9 over 45 is 1/5. And then 12 over 60 is 1/5. So your k value is 1/5. All right, so that's the lesson for you. If there's time left in the class, you can discuss with your group of 4. What did I learn today? So discuss how can you tell if a table is linear or nonlinear. Also, if a table is proportional or non-proportional. All right, have a good day. See you tomorrow. I hope to get a good report. Have a good day. Bye.